Hey guys, what's going on? You're about to see a coding interview that me and Mircea did. He actually interviewed me and he gave me a pretty tough problem, I'm not gonna lie. But you are going to see how I managed to solve it. You are going to see three, maybe four different solutions to that problem. And I'm going to give you 10 tips about how to nail the coding interview or how to interview someone during the video. So in order to get the most out of this simulation, make sure you are focused, make sure you take notes, and make sure that you go to AlgoCademy.com and solve the problem, whatever one of the four different solutions that we will talk about. Solve it on AlgoCademy for free, submit your source codes, and let us know how it goes for you. Enjoy. Should we start?
Yeah, of course.
I guess we should. What's up, Mircea? First of all, let all the subscribers know who you are because they don't know you yet.
Hi, Andy. Hi, everyone. I'm a senior software engineer and co-founder of AlgoCademy, and I've been training high school students for competitive programming for a decade now. So I really have this teaching experience as well as Andy.
Yeah, you're an original gangster of this. Yeah, so guys, you probably know me. It's Andy, co-founder along with Mircea at AlgoCademy. And today we are going, as I've said in the intro, to simulate a coding interview together. Mircea is going to be the interviewer. I am going to be the one that applies for that job. So yeah, let's make the most out of it and make it fun. So Mircea, what did you prepare for me today?
Right. So hopefully you'll get the job at the end. So I'm going in the Google Docs.
All right.
And so you are given an array, let's say nums equals 3, 5, 4, 2, 1, and the value k, which should be 3. And I want you to find for every k consecutive items, k consecutive numbers, you compute the maximum value, and you return it as an array. So let's say maximum of 3, 5, 4 is 3. Maximum of 5, 4, 2 is 2. And maximum of
That's not a minimum. Sorry
4,
for.
what?
That's not the minimum.
Maximum. It doesn't matter. It's the same problem, but 4 to 1
Alright.
is 1. Oh, so you're saying right. So it's 5,
Okay.
and 4.
Yeah.
So you need to return 5, 5, 4, like this.
I see. Alright. So I am given the array nums and the integer k, and I should return another array of integers, right?
Yeah.
Alright. That is pretty cool.
So I think I'm gonna give you also the template, because we'll probably end up submitting it to AlgoCademy in the end.
Alright. That's nice.
So we can use this as a template. Yeah.
Oh, yeah. Alright. Nice. Cool. So, alright. So I guess I have integers. K, I think it is always less than or equal to the length of nums, right?
Yeah, you're right. Yeah.
Yeah. And alright. Cool. I think I understood it right, the statement. Yeah, first of all, the first thing that comes to my mind is obviously a brute force approach. What can I do here is just iterating through each sequence of k consecutive integers like 3, 5, 4, 5, 4, 2, and 4 to 1. So in order to iterate through these sequences, I just need the first index of the sequence. So basically for each index from 0 to n minus k, I think, n minus k minus 1. If that's, something like that, I think n minus k or n minus k minus 1. And then of course I will make a second nested for loop to get the maximum, right? So I have an big O of n crossed k.
Right.
For
Yeah.
this brute force approach.
That sounds good. Obviously, this is too slow.
Yeah.
So we'll want to think of other solutions which are better.
Alright. Interesting. So I need to get the maximum among all these k numbers. Okay, so the problem is that basically I can get the maximum for the first k numbers pretty easily. I can make a for loop and get that maximum, and then from a sequence to the next one I basically have a new element, but I also got rid of the first element, right? So it works like this: if I know the maximum, or if I know the first sequence, then I always add a number, get rid of a number, add a number into the set, get rid of the number.
Right, yeah,
And
that could work.
I'm going to need something like a data structure which can do that, which is powerful enough to let me add integers, subtract integers or remove integers, and then give me the maximum. So of course, as we know in the classical data structures, this is the job for a max heap. So I think I can use a max heap in which I will first insert the first k integers, like in this example,
Okay.
3, 5, 4. Then for each sequence I can get the maximum out of the max heap, and of course that will be the current element, right, in the solution array. And then to move to get to the next sequence, I basically have to insert the new element, and I have to get rid of the previous element. But that's a big problem, because in a max heap I can get rid only of the maximum element. So if that first element is not the maximum, then it's not good. I won't be able to do that. But still, there is a data structure that can do that. It's a little bit more powerful than the max heap, which is the set, right? And in a set I can search for a value, and I'm going to have a pointer at that value, and I can remove that value. So I can actually use a set instead of a max heap, and that should be fine.
Right. But will it work if you have duplicate items, duplicate numbers?
Oh, that's a good question. That's a good question. Yes, I think it will work. Yes, because it doesn't matter if, let's say, I have a couple of values of 5 and I have to remove a 5. It doesn't really matter which one of them I will remove, right? So
Yeah, but normally a set keeps unique items, unique numbers.
right. I should use a multiset. Yes.
Yeah.
Yes.
Okay.
A multiset should do the trick.
So normally a set and a multiset is quite a heavy data structure compared to a maximum heap. Obviously, it's easier to implement for this problem, but you can actually use something with a maximum heap to actually remove items from anywhere. Do you know how to do that?
Let me think. So I can use something like the maximum heap that can...
No, just the maximum heap, but also be able to remove specific nodes.
Oh, I see. That is interesting. Let me think a little bit. Alright. So I will be able to... Oh, I think I got it. I think so. So, if I have the max heap, right? In a max heap, I can basically insert a new value. I can insert a new node, which is basically done by making a node with that value and having it at the end, like the last node in the in-order traversal, let's say. And then, of course, I will apply the up heap function, and I will move it up and up and up until I find its place. When I want to remove a node in a max heap, what I think I can do, if I remember this right, is that if I know the specific node, I can swap that node with the last node. I can remove that last node, right? So Yeah, I can remove that last node. So basically I have removed the node that I wanted to, but now I have that node which was swapped with the last one. That last node is now on a position which it shouldn't be there. So I have to also up and down heap that node, right?
Yeah, sounds good.
Yeah. So
Also, you probably need to keep track of where the
yes.
each value is in the max heap.
Yes. That's exactly what the extra thing is. As we know, the max heap is basically stored as an array, so I can have an extra array for the positions, like value positions, but it shouldn't only be an array. I have a question for you. How large can be these values? Can they be negative? Can they be pretty large? Like
The numbers in nums, you mean?
yeah, in nums.
It can
Yeah.
fit in 32-bit integers.
Oh,
Integer. Yeah.
I see. All right. So that's definitely not the job for an array because an array is zero indexed and has a finite number of positions of values. So I should have again a data structure which basically binds the value from nums and the position in the max heap array where that value is. And because these values in nums could be negative, positive, and pretty large, an array is not enough. I have to use an unordered map for that job, or a hash table.
Yeah, sounds good.
Yeah.
All right, so this solution is interesting. We're not gonna code it because you basically have to implement the whole maximum heap.
Yes, by hand.
Yeah. Maybe do you want to code the multiset one first and then keep going with the solutions, or just think about other solutions now and code later? It's up to you.
That's interesting.
I think it's a fast code.
For the multiset.
Yeah, the one.
All right. So we should do it. All right, we can do it, and then maybe think of other solutions or faster ones.
Yeah.
All right. So I have nums and I have k, and basically, let's recap this a little bit. I'm going to use a multiset. Oh, all right. So I'll have a multiset, and initially I'm going to have the first k integers in that multiset. So let's say we have a multiset of integers, and let's call it vals. I mean, yeah. This, let me top this. Oh, the indenting is pretty horrible. Let's use this. So I have a multiset and I have to insert first the first k elements. I don't know if is there any constructor for the multiset which uses two pointers, two iterators, like I don't know if for multiset it is, but for vector I'm sure it is. Like I can do something like nums.begin, so I give the first iterator.
Yeah, it should work. Yeah, I think
work?
it works. Yeah.
All right, and nums.begin plus k.
So you're creating, okay, the first, you're pushing basically the first k into
yes.
the yeah.
I'm pushing the first k integers into this multiset vals, and then what I need to do is this first k elements correspond to the sequence that ends in position k minus 1. So in order to iterate through each sequence of k consecutive elements, I will have a for loop to iterate through each end point of these sequences. So this should start at position k minus 1 and should go all the way to n, which n by n I want to note just for an easier job. Okay, by n I want to mean nums.size, so less than n I plus plus. So basically on this current step, right, on this current step when I am with I have in the multiset those integers, so I know what is the maximum value, which should be, if the multiset is vals, I'm going to need vals.end, but vals.end minus 1, because that's the last element. So this is an iterator now, so I need to uncast it, I think, to get its value, but I need to store this value somewhere, so I'm going to need a vector for that, for the answers. So alright, vector of integer answer, and yeah, basically what I need to do is to push into the vector of integers, push back this this greatest element, because they are sorted increasingly. Alright, cool. So I have this for loop. I know the answer now, and now I have basically to get from the current one to the next one, right? Which I will do by adding the new one and subtracting the old one. So basically I have a better idea. Because we already had all these k first elements into the multiset. Let's do this first, not inside the for loop, because I think it's easier. So first answer that push back this last element, and then I can start from the endpoint k, and now when I am inside the for loop I need to get this new sequence. So basically what I'll do here is that now I will push into the vals. So vals, I will insert this value, which is nums of I, and I should get rid of the value nums of I minus k. Yeah, because that was the first one of the previous sequence. So nums of I minus k, I think I should find this value with an iterator and then erase that. I don't know if, yeah, I think that's the way to do it. So vals dot find, and the value is nums of I minus k, and this gives me an iterator. So then I should erase the value, the element of this iterator. So I have inserted a new one, erased the old one, and then I basically know the answer, so I push this greatest value. And after this for loop terminates, I think I should have the answer right, so I should just return it.
Right.
And I think that should be it.
Okay. So one thing, actually two things.
Okay.
Obviously, it would be been more elegant if you didn't use answer.pushback twice, as you initially wanted, but that's fine. Do you want maybe to submit it on AlgoCademy?
Yes.
Okay.
Sure.
I have a feeling you'll get an error.
An error? All
or
right.
a runtime error. I don't know.
All right,
Yeah.
that's a challenge.
Yeah.
So, all right, guys, I'm entering AlgoCademy, as you all know, the best platform to prepare for coding interviews. And yeah, first of all, before submitting this, I should say that you should definitely check it out, because we have a new section on dynamic programming. It's a new learning path. And Mircea, how many problems do we have for the subscribers for free? How many do we offer?
We have 7 now and 15 interactive tutorials.
Oh, that's pretty cool. So if you go to algocademy.com and start the dynamic programming learning path, you will see that you will have 7 problems and 15 interactive tutorials that we offer you. So yeah, get the deal and start working on dynamic programming. But for now, I am going to the general arena. And what is the problem, Mircea?
The first one.
The first one.
0.
Oh,
index.
0 maximum sliding window. All right, I found it.
Yeah.
All right, cool. So let's copy paste this code, this class solution, right? So basically, I forgot to say the time complexity of this solution is, of course, big O of n log k, because we have the multiset. We search for the element, we erase the element, we insert a new element. So yeah, we do 3 operations that are big O of log for each of the n elements.
You said n log k or
n log, yeah.
okay, because you have k items in the step.
Yes. Good. So now I think we need to do better. We need a linear time approach, which is an interesting one. Let us think. So obviously I need again to simulate this process of getting from a sequence to another. So inserting an element and removing an element and always getting the maximum. All right, so first of all, this is a sliding window problem, as the title suggested, because we are moving with 2 pointers, always increasing both of them. And my experience on solving coding interview questions and solving a couple of ones on AlgoCademy tells me that the data structure that it's right. I mean, the data structure that usually solves a lot of problems with the max sliding window technique is the deck. So when I say maximum sliding window technique and I want to find the maximum or the minimum, this is actually the classic problem that I think the data structure deck was designed to solve.
Right. Yeah.
Yeah.
By the way, I increased the time limit, so maybe you can submit and show that it actually works.
Yeah. All right. Let's show to the people. Will it work? Oh, it works. All right. So accepted. Yeah. All right. Cool. So yeah, now that it works, let's start thinking of the linear time approach. Yeah, so as I've said, it was the deck which does it. Right. And this is very interesting because the mechanics of how the deck works are pretty interesting. So
yeah, I also want you, when you to showcase like a simple example how the deck works. Maybe you can write something.
Yes, that's a good idea. So all right. Basically, let's see what the deck does. So I have this array, right? 3, 5, 4, 2, 1. All right. So this is nums. I will have my deck, which I don't know how I should call DQ, let's say. If this is the deck, right? I will iterate through each element from nums. So 3, 5, 4, 2, 1. And for each element, I will insert it in the deck. But I will still make sure that the deck has always at most k elements. So for the first k elements, for the first 3 elements, it's not a big deal. I will have 3, then I will have 5, then I will have 4. But there is still one more problem. If let's say I add these elements like that, 3, 5, 4, okay, where is the maximum one? Because I should always know and get fast the maximum one. So yeah, here the maximum one is in the middle, so obviously I won't know if it's position 2, 3, 4 or whatever could be. So what is the trick with the deck is that you will always want to keep those current k elements, or at most k elements, sorting, either increasingly or decreasingly. And because we want to get the maximum element, it would be nice to have those elements sorting decreasingly. Because if we do that, we know that always the maximum element will be the first one. So, for this example, actually, what I'll do with the deck is that I have the current element, which is 3. I add it as it is the only one. Then I have 5. If I insert 5, I have 3, 5, which is not good. It has to be decreasingly. So, if the deck is already sorted decreasingly and one new element comes, what could happen is that this current element, which is 5, could be greater than the last element in that deck. So as long as that happens, I can't insert the new element because the deck won't be sorted decreasingly anymore. So I have to first get rid of those elements from the back which are less than the current element. So I will remove 3. Now after removing 3, I don't have any element, so obviously I have 5 in the deck as the only one. Then it comes 4, which is going to be the current element. 5 is greater than 4, so if I just add 4, the deck is going to be sorting decreasingly. So now what I've done is that I've taken the first sequence of elements. I have my deck which is sorting decreasingly, and the first element of the deck is going to be my answer, right? So if let's say I have the answer here, the answer array, I will push 5 into the array. Now, let's see what happens for the next sequence. Then the next sequence is 5, 4, 2. So the current element now is 2, which should be inserted into the deck. So I take a look at the deck. My deck is 5 and 4. So if I insert 2, the deck is still sorted decreasingly, which is very nice. But I have to make sure now that because the sequence is 5, 4, 2, this 3 won't be in the deck, this 3 cannot be a solution anymore because it is not part of the current subsequence. So basically now the deck is 5, 4, 2, and because 3 is not in the deck, everything's fine. We will see how to do that for the next subsequence, because here comes a problem. The next one is going to be 4, 2, 1. The current element, of course, is going to be 1. So again, I can just insert 1, which is fine. But I have to make sure that 5 is not part of the deck anymore. And what's interesting is that 5 is actually in front of the deck, right? Is the front of the deck, which is very awesome because, as we know, in a deck we can insert and remove elements from both the front and the end in constant time. So I can just remove this 5 in constant time, and now I have the elements from the sequence sorting decreasingly, and I know the answer from the deck, which is 4. So yeah, I forgot for the previous sequence to also write the answer here. So 5, 4, 4. So just as a recap, I will always want the elements in decreasing order. When the current element is greater than the element at the back, I will always remove those elements in constant time, and then I will insert the element. So I know that the elements in the deck are sorted decreasingly, and the problem is that I should always make sure that when I move to the next sequence, the element that is now old, which is nums of I minus k, is now not part of the deck. And this is also going to be achieved by just checking what is the first element in the deck. Because not only these elements are going to be sorting decreasingly by value, but because we iterate from the left to the right, they are going to be sorted increasingly by position. So, the first element in the deck is also the greatest one in value, but the smallest one in position. So I should just take a look at that element, and if its position is I minus k, that means this is the bad one. I should remove it as it is not part of the sequence, and this is it, right? Yeah, so that's basically how the deck works. And just for the time complexity, to make it clear that it is indeed linear, it can seem not to be linear because as we will write the code, I will have a for loop to iterate through all the elements, and then I will have only one while loop for getting rid of those elements at the back of the deck which are less than the current one. So you will see a for loop and a while loop. But this is actually right because if we think overall, what happens is that each element from nums is inserted exactly once in the deck and removed at most 1 times from the deck. So even if I have two nested loops, the number of operations in total is at most 2 cross n or something like that.
Right. Yeah, it sounds great. Do you want to code this one? Because I also have a follow-up, so it's up to you if you want to code this one or maybe think about the next one.
Let's do the follow-up.
Okay.
The coding part is classic.
Yeah, that's what I was thinking.
Okay.
So what is the memory time complexity of both these solutions?
Okay, of both, right. So the first one, which uses an unordered set, well, obviously because we receive the vector nums, we will have big O of n from there, but the extra memory...
the extra memory,
yeah. The extra that we use in the first one is big O of k, because the unordered map uses always k elements. That's its size, at most k. And the first one is still the same. Yeah, our deck has also at most k elements. Yes.
Exactly, yeah. So the follow-up is, can you do it with big O of constant time, constant memory, extra memory? You can use the nums array and the result array, but you cannot declare another array, for instance, for data structure.
All right, I see. All right. I see. That's interesting. So constant extra memory. So I can overwrite the nums array, right?
Yeah, you can modify them. Yeah.
Okay. That is interesting. Huh. That's pretty nice. That's pretty nice. This is actually a very, very important thing if I can override the nums, because I'm pretty sure that at any point I need to have k values somewhere. I need to have the greatest k elements or the current k elements stored somewhere in some order. But because I can overwrite nums, I can actually make the same solution with the deck, but instead of having an extra array which is the deck, I think I can store those elements, the at most k elements that I need to have in the deck sorted increasingly, directly in nums.
Okay.
And this is going to work because I know it might sound, if I overwrite nums, don't I lose any important values? So what do I do with them? Yes, but at any moment of time, if the current element is at index I, let's say, like here, if it's the fourth one or the fifth one, the deck always will have elements that are previous ones and are less than I. So if I store the elements from the deck, the size of the deck elements as being the first size of the deck elements in nums, I won't lose any value because I've already processed those, right?
Okay.
Yeah, and because now I don't have the deck like the data structure, I'm going to do it by hand. So I'll need to have two pointers in nums, which one is going to be left or front, one is going to be right or back, and I'm going to do this manually, decrementing or incrementing front and back, basically.
Right. Yeah. So this is a different solution than mine. I actually thought that the deck would also work. Do you want to think of another solution? So normally people who apply for coding interviews don't really know about the deck. It's more of a competitive programming stuff.
Mm-hmm.
There is a solution for this, which is linear.
Mm-hmm.
And it doesn't involve any data structure.
That's interesting.
Yeah.
All right. Yeah, sure. Let's think about this. Let us think about this.
Let me know if you need hints, because it's not a hard solution, but you probably need hints.
All right. That's interesting. I'll let you know.
Yeah.
All right. So I need the maximum. Again, the values could be 32 bits, right?
Yeah.
Okay. Okay. I'm thinking a little bit. I think we have to solve this problem in kind of a different way to have a different picture. One idea of mine, it would be like, if let's say I know where the maximum element from nums is, that element I know for sure that there are going to be, I think, 2 crust k minus 1 sequences, which it is going to be the maximum one from there. So let's take an example. For example, I don't know, if nums was, let's say, we have this 5 and I don't know, maybe we had 1, 2, 3, 4 here, right? If I know that 5 is the maximum element in nums and k equals 3, then I know for sure that for this sequence 5 is the answer. Also for this one 5 is the answer. Also for this one 5 is the answer. So yeah, not for exactly k sequences, for at most k sequences, it depends where 5 is, because if 5 is the first element, then just for one sequence is going to be the answer. I don't know if this helps a lot. It's just an idea that came to my mind.
Right. So first of all, let's drop the memory constraints. You can declare two more arrays, for instance.
Two more arrays?
Yeah. of size of length nums.
Of length of nums. Alright, I can do that. Interesting. It's interesting because you said two of them. Why do I need two of them and not only one?
Yeah.
Is it something about having, I don't know, the values sorted or something like that?
No.
Not really, huh?
No.
I think I'll need another hint.
Okay. Yeah.
Yeah.
So one first hint is maybe you can split the array into buckets of size k.
Okay. So first k elements, next k elements, next k elements, and so on, right?
Yeah. Yeah. So we'll have 1, 2, 3, and then 4, 5, 4, and obviously 2 and 1.
All right. Okay, so if I do that, obviously, yeah, I'll know the answers for these sequences, which are the buckets, right? The maximum
Right.
one.
Yeah.
So basically, one sequence is either an entire bucket or it has some suffix from a bucket and some prefix from the next one, right?
Yeah.
Like 2, 3, 4 or 3, 4, 5. Okay. Okay, and if I want the maximum, okay, so if let's say I have basically one sequence which I have a bucket of elements, of k elements, then I have the next bucket of k elements, and I know some sequence maybe has x elements from here, so the last x elements from here and the first k minus x elements from the second one, right?
Yeah.
Basically, if I need the maximum of this sequence, I'm going to need the max the max, let's say, suffix val from the first bucket and of course the last x elements, and the max prefix val from the second bucket and k minus x elements, right?
Yeah. Yeah, you're on the right track.
Yeah, so if I split this array into buckets of k, I think I should pre-compute these arrays.
Yeah.
Max suffix val and max prefix val for each bucket. And when I do, I can know in constant time what is going to be the maximum value of some sequence.
Exactly. Yeah.
Yeah. Okay.
So now the constraint is you cannot declare those two arrays.
I see. That's nice. Okay. Yeah. So with those declared, yeah, I have to have a big O of n. I will have memory. But now without them, that's interesting. Okay, so
remember you also have the answers array you can use.
Yeah.
Which is n minus k plus 1 of size.
Oh, okay, I can use that.
Yeah.
Oh, I see. Now it
you have two arrays already.
All right. Yes, that's right. Now everything makes sense. Yeah. So basically, when I split this array into buckets of k, I will again iterate through the sequences. First sequence of the first k, then the next one, and so on and so forth. So if this is the current sequence, right, and I know this maximum, max suffix val, let's call it a, and the max prefix val from the next bucket, let's call it b, for example. If let's say I have two variables, or I know those, when I move to the next sequence, b is very easy to be computed because I'll have the maximum between b and the next element. That's easy. But the problem is on a, because from a, now we will remove the first element, and that could have been the maximum. So I think the real problem is with this max suffix vals. But we can use the answer array. That's cool. If we can use the answer array, I think that I'm going to do this. So after writing nums, splitting it in buckets, I am going to fix each bucket from the first one to the last one. So let's say I have fixed this bucket 1, 2, 3. I know that I'm going to have some sequences which will contain some suffix from this bucket, right? Either the whole bucket 1, 2, 3, either suffix 2, 3 and 4 from the next bucket, either suffix 3 and 4, 5. So what I want to do with this bucket is compute the max suffix val and have it stored into answer, those values. Can I do that? Yeah, I think I can. But I have to make sure I need to make sure to store it some. Oh, I see. I think I see. So the answer array has the length n minus k plus 1, right? Can I use n elements from that vector or that array?
You mean to declare it as size n?
Yeah.
No, you cannot.
I cannot, right? Because I wanted to store this max suffix vals as the last elements, because I'm afraid to not overwrite.
Right, yeah,
the current
that's what I
answer.
did initially, and then I figured out how to use it without that.
Yeah, we have to make sure that we. Oh, I think we can do that actually. It's not that hard. All right. So if this is the first bucket, then it's basically okay, because answer doesn't have any values, right? We don't know any values from the answer. So basically, if I want to compute this max suffix val and store it into answer, I don't have any values to be afraid of. But also we have to make sure, because we will compute k values with this bucket. When I have the first bucket, I'll have k answers, k sequences that I'm going to compute here. All right, that's a little bit more trickier than I thought. Yeah, but I can use nums.
Yeah.
I can also use nums, right? If I can use nums, I think I can replace the actual values in nums with max suffix, and that's it.
Yeah.
Because if let's say I have this bucket 1, 2, 3, right? I don't need the values in nums here to be 1, 2, 3. I need to use the bucket to compute the max suffix vals, which is 3, 3, and 3, and I can override these values in nums. They can be now 3, 3, and 3. Right? Yeah, okay. And yeah, now basically everything's alright, because I know the answer for the first sequence, which is this 3, so I can have 3 here. Then when I move to the next sequence, the last value is 4, so I'll need the maximum between 4 and this 3. And this 3. Yeah, this 3, yeah, which is 4. And then when the next element is 5, I'm going to have in a variable the maximum between these two, which is 5, and this maximum and this value, I guess, which is again 3, and I can store it here. So I think, yeah, that's how it should work.
Yeah, I think it should work.
Okay. So, yeah, let's think a little bit. I'm thinking a little bit about the code.
Yeah. So I'm not sure about the result array, how you'll actually store it, because in my implementation, I've actually shifted the numbers in a way, meaning that the result of 0 stores something like the the prefix, I think, of k or something like that.
Mm-hmm. Mm-hmm. Yeah,
So maybe
I
that could
thought a
help.
little bit about that. Yeah. So you are not overwriting the nums. You are
Uh,
you are
I
using
am
answer. Oh, you are.
I am overwriting nums and using result.
Okay. So are you overwriting the nums like how I do with the max suffix vals, or
Um, so suffix is at the end.
yeah?
So this is okay. Um, result. Yeah. It's the suffix I'm
Oh,
using
all right, all
for
right.
result actually. I'm actually using the suffix for result, and for nums the other one.
Oh, the prefix. Oh,
Uh,
so you use both of them to store both of this prefix and suffix. Yeah,
yeah,
yeah. It's kind of the same solution, just that um, instead of computing the max prefix val, I don't think I need to, because this max prefix, as I've said, we only insert new elements. So I think we can have just a variable for that. I'm not sure, I might be wrong, but
yeah. I think it works with a variable. Yeah.
yeah, I think it
Let's
should
try
work.
it. I mean, yeah.
Yeah, why not? Let's find out, right? So, all right. Good. So I have nums, I have k, and we will have the vector for the answer. So let's say of size n minus k plus 1, right?
Yeah.
All right, so n minus k plus 1. And now, okay, we should split this into buckets of k. All right. So, I think I should fix um, the index of the bucket. Like, we can index the buckets starting from 0. So let's say this is for b, from bucket. From bucket, from 0, bucket. Yeah, we have to be a little bit careful about the bucket. But I think, how many buckets could there be? N divided by k.
Yeah.
7, 3. Yeah, I think so. Yeah, we might have another extra bucket, but if n is 7 and k is 3, for example, we have buckets 0, 1, and 2.
Yeah.
So, okay, I think I can have less than n divided by k. Bucket plus plus. Alright, cool. So now I basically know the bucket. So let's have two variables to what is the first index of this this bucket, this subarray. So let's have here some I don't know, left, which is bucket crossed k, and the right pointer, which is going to be okay, that's cool. Theoretically it's bucket plus 1 crossed k minus 1, I
Left
think.
plus k, maybe.
Oh,
Left plus k.
or yeah, left plus k. Yeah, that's easier. Left plus k. Yeah, so int right is left plus k, but I have to make sure also Or shouldn't I? I think it's okay. Yeah, I think it's okay because this right is not going to surpass n. I hope not be greater than n because I have this n divided by k. So that's so tricky.
I'm not sure.
Yeah, that's pretty tricky.
Maybe you can say right is minimum between n and
Yeah,
left plus k.
I can, and yeah, that is going to be safer definitely. So yeah, the minimum between this and n, right?
Yeah.
Okay.
N
Cool.
minus. Is it the right like included or excluded?
I think it's excluded. Because
Okay, so maybe it's n minus 1 there.
well, if right is excluded, shouldn't it be n? Like in the for loop, I'll have from left.
Oh, okay.
And less
Yeah, I
than
get
right.
it.
Yeah, okay. So yeah, now I think we can iterate through those elements. So for int I equals left I less than right I plus plus. Okay, cool. And now I have this element, but what should I do is to compute the suffixes. So in order to compute the suffixes, I'm going to store them in answer. Yeah, of course. So I can, to compute the max suffixes, vals, I should start from actually from right minus 1, going all the way to left, and each time decrementing the I, so I minus minus. Alright, and now I will basically replace nums of I by max suffix of I plus 1, which is nums of I plus 1. So when I compute the max suffix, I take the previous suffix, which is now nums of I plus 1, and basically the current value, which is nums of I. So now from left to right minus 1, I have the max suffixes in nums actually. And now when I want to compute these answers, let us think. I can go with the pointer from left less than right. Okay, so I know the suffix, right? I know nums of I is now going to be the max suffix that I care about. But I need the maximum from the next prefix from those elements. Man, this is tricky to implement.
Yeah.
Alright. So how many elements do I have there? How should I do it? Okay, so as I said, I'll have another variable, so max pref, which I have to be careful because the first one is going to be theoretically nums of right. So first of all, this nums of right is actually for left plus 1, so I will start from there. So for the whole bucket, the answer is clearly nums of left. I know that for a fact. So for the whole bucket, it's nums of left. So yeah, that's going to be the next element. So there's no need actually here to, I can have the answer to be empty because I want to push back each time. So I can push back the nums of left, which is going to be the maximum from the bucket. And now I start with the max prefix of nums of right, and I start from left plus 1, and yeah, answer dot push back the maximum between nums of I and this max pref, and then I have to update the max pref because I moved to the next sequence. So max pref is the maximum between max pref and that's interesting. What's going to be the next element? I think it's right plus I minus left minus 1. Right plus I minus left minus 1. Because, yeah, to right I'll have to add the difference, like the current step. Alright, cool. So I have max pref, and I'll just update max pref. So I think, yeah, that's it for the current bucket. I have left, I have right, I compute the max suffix. Okay, I think that's okay. I think that's it. I think I have to submit to really know.
Okay. In answer, how many? Oh, you actually push it. Okay.
Yeah.
Yeah. Yeah, let's submit it. I mean,
yeah,
sure.
yeah. Just to return the answer here because I forgot.
Yeah.
The size of the answer is right. It is indeed n minus k. Because I push at most n minus k plus 1 times. So let's paste it. Cool. Yeah. So that's basically my code, right? But it's arranged.
Yeah.
Okay. Okay. Sure. So let's submit it. See what happens. So it's failed. Oh, no. All right. Good. Now I have output, which is
Yeah.
which is a good sign. Okay, so let's see. I have 3. I have 3, which is not bad. I have -1. It's not that bad.
Close enough.
Yeah, really close enough. I have. Yeah, I print too many. I print too many of them, which is not cool. But I think now it's going to work. It's n divided by k. Yeah, it's accepted. Yay.
Oh, nice,
Yeah.
nice.
So the problem was that the number of buckets, initially I got it right, it's n divided by k, but let's see on docs. So it is
Right.
actually n divided by k. That's the number of buckets.
Yeah.
Because you don't need the last bucket, which is less than n, because you won't start there. So that's what you need. But the problem was that I had to limit here this for loop, because I've had some sequences which actually were getting out of the bounds of the array, which is not good. So that was the problem.
Right.
Yeah. But anyways,
So I have a question.
Yeah. So that should be it. What's the question again?
So the question is, do you think it's actually big of 1 constant memory, extra memory? Because I can spot something that it's not good.
Interesting. Let's see. So is it actually constant extra memory? Well, I use nums, which is okay.
Yeah. What's the size of answer? I mean, how much space does it occupy?
Answer, the vector answer.
Yeah.
It's n minus k plus 1.
Not really. The thing is, you push back to it.
I see.
Yeah.
Nice. That's tricky. Yeah. It could be.
You need to reserve the size.
That is right.
Yeah.
That is right, because it can get double. It could be
exactly,
two crust.
Exactly.
Yeah. So I can just reserve and then I can push back. No,
yeah,
right?
Of course. Yeah.
If I reserve. Oh, okay. And if I reserve, I will still be able just to push back, right?
Yeah, it's empty. It's still empty, but it allocates exactly the size you want.
Nice. That's very good. So answer that reserve and minus k plus 1, right?
Yeah.
Oh, all right. That's nice. All right. Cool.
All right. Yeah.
That was it.
Seems like, yeah. I think it was a pretty interesting interview.
Yeah, it sure was. It was fun, but
yeah.
but very, very hard. Like the ideas were fine, but if you're not experienced and not in good form, in shape with the coding, yeah, you can get very stuck. You can get stuck a lot.
Yeah, obviously, just The first two source codes were just fine for an interview. The last one was just to push you further and to
Yeah.
give you something that you didn't know,
Yeah.
basically,
Yeah. Yeah.
and to see how you react live, basically,
For
to a
sure.
new problem. Yeah.
For sure. That's an alternative solution to the deck, which is pretty awesome. Yeah, it
Yeah,
is.
yeah, I really enjoyed it when I saw this. Yeah.
All right. All right. Cool. So thanks a lot, Mircha. For the guys watching, I hope you enjoyed this problem. I hope you enjoyed this interview. I hope you got very nice insights about how an ideal or almost ideal interview should look like. You should ask a lot of questions. You should ask for hints when you need them, and you should always express your ideas with the interviewer because he needs to know what you think about. This problem was of course very interesting and not that easy, but if you want to make the most out of this video and the interview, make sure you go to AlgoCademy and code your solution to the problem. You can code one of the 3 solutions that we have discussed, maybe one of the 4 actually solutions. I think we have come up with 4, and yeah, maybe another solution that you thought of and you want to test it. Go to AlgoCademy and you will have in the general arena, you'll have the problem 0 maximum sliding window, so you can do that. And also, because we want to give you something for free, we have just released the dynamic programming learning path. It's not completed yet. We will have more lessons and more tasks for this, but you can go into the learning path, click on dynamic programming and start coding the problems here. You will see that we have also, of course, video tutorials if you want to give a hint.
We are given a pause.
And you can then code the solution along us, which is pretty amazing. So make sure you do that too. And yeah, I guess we'll see them on the next one, right, Mircha?
Yeah, of course.
All right, see you on AlgoCademy, guys. And Mircha, thanks a lot for the interview. Have any additional notes to say, or?
Not really. I think you did quite well. The last problem was quite hard, the last solution, and it's fine that I needed to give you hints. I think it's a mostly pass. So yeah.
All right. Thanks. So this was it. It was fun, and yeah, bye guys. See you on the next one.